So hello friends. So previously I have discussed some problems about Grignard's reagent. So you can watch those two videos I have already mentioned. So now I will give another problem that is asked already in GATE 1991. So this is a subjective type of question, not objective. So they have asked predict the major product in the following reaction. So they have given a cyclic ketone having a tertiary butyl group and treated with Grignard reagent, then work up. So what will be the major product? So the answer is major product is like this. CH3 will be at axial position. So you can see that is 51%, 49%. I will tell you what is the reason behind this. So let me explain two type of attack, that is axial attack and equatorial attack. So this nucleophile will approach from axial side also and from equatorial side also. If it attack from axial side, then this will be predominant, and if it attack from equatorial side, then this product will be predominant. So what is the reason why this product predominates over this? So the reason is hyperconjugative interaction. When this incipient CH3C bond approaches the antibonding of this carbonyl group, there will be hyperconjugative interaction as this group and hydrogen are in trans. So there will be a hyperconjugative interaction between these two molecular orbitals. So this will be more stabilized. Now if you see the approaches from equatorial side, there will be no hyperconjugative interaction, rather you can say steric interaction between these two orbitals, because the orbitals are not properly aligned. But in hyperconjugative interaction there must be trans, and the hydrogen must be trans to the incoming ligand. So here you can see there is no hydrogen are present trans to this group, so no hyperconjugation takes place. So this system will be not that much stabilized. So that's why this equatorial attack will less favored as compared to this axial attack. So remember, whenever there is attack in this 6-member type of system, axial attack will be more favorable than equatorial attack. So this much information for this question. So 51% with this axial CH3, this will be the major product. Now come to the next question. So which of the following option is the most likely product formed in the following reaction? So they have mentioned a cyclic ester. So now they treated with Grignard reagent, then work up. Based on that, they have given 4 options. One of the option will be correct answer. So the correct answer will be option D. So how, that I will explain you. So these two carbons are nucleophilic. One of the carbon will attack first to this ester. So you can see one of this carbon, I have taken this carbon. So this carbon is nucleophilic and this is electrophilic center. So this will attack, then this will goes away, and when it come back, this ring will be open. And in oxygen, it will attach to magnesium bromide, and this magnesium bromide is always there. So now when you rearrange, you can see there are 1, 2, 3, 4 CH2 group after carbonyl. So 1, 2, 3, 4. Now this is act as the internal nucleophile, and this will attack to the carbonyl carbon. As a result, a 5-membered 1, 2, 3, 4, 5-membered ring is formed, and OMGBr when hydrolyzed, it gives OH. So if you see in another angle, it will look like this, and which is the correct answer? It look like option D. So option D is the correct answer. Now move to next question, which is asked in CSIR June 2015. So the major product A and B in the following synthetic sequences are. So they have given a cyclic alpha beta unsaturated carbonyl compound. So they first treated with phenyl magnesium bromide, then copper iodide, then hydrolysis, then sodium ethoxide bromine. So what will be A and B? That I have to mention. So they have given 4 options based on that. So what will be the correct answer? So first, if you see the mechanism, so phenyl magnesium bromide is present in presence of copper iodide. If only phenyl magnesium bromide is given, then that will attack to 1-2 addition take place, that will attack directly to the carbonyl. Because of this presence of this CuI, copper iodide, it will the nucleophilic character of this phenyl will be decreases. So it will not attack to this position, rather than it will attack to 1-4 addition takes place. So this will attack to 4 position with respect to this carbonyl group, 1, 2, 3, 4. So this will attack to this, because this will act as a soft nucleophile and this is the soft electrophilic center. Now when it will attack to this position, this bond will come to this position and this will be open up. Now if you see, there are 2 type of attack. There is phenyl will attack axial position or phenyl at equatorial position, because it will attack from axial side and also from equatorial side. And cyclohexane are more stable in cyclic chair form. That's why I have mentioned in cyclic chair form. And one is from axial side and one is from equatorial side. As we know, axial side attack will always take place. So we have done axial attack. And if you see the equatorial one, there will be some allylic strain. So this will be unstable. So this will not form. So we will move with this axial position having pH. Now when this negative charge of this oxygen comes to this will attack axially, because axial attack is more favorable. So this protonation will also take place from axial position. So this proton will come at axial position. If one group is axial position, another will be equatorial. So this ketone group will be at equatorial position. Now you can see clearly, this is above and this is also above. So above is cis. If it is below, then also cis. If one of them is above and one of them is below, then that will be trans. So both this group are above. So this is cis. So this will be the correct answer. So between option 1 and 3, one of these option will be correct, because we have A in cis fashion, this is in trans, so this will be incorrect, this is also incorrect. So now we will move to option, that is what will be the B. So now if you move to next slide, so now if you see, this is cis, above, we can represent also like below. So this is below and this is also below, this is also cis. These two are basically same molecule, they are not different. Now when you act with this sodium ethoxide, this will epimerize this and this group will come at axial position. So this will become now trans ketone, that is one position is above, one is below. So this will be trans. Now if you see the mechanism, this trans ketone, they have 2 type of interaction. That 2 type of hydrogen are also there. This sodium ethoxide will take proton from this methyl or from this hydrogen. So if it will take this proton, that is axial proton, it will form an enolate. It will come like this and this will open up. So there will be formation of this type of intermediate. So pH will be here and the enolate will be at the double bond will be here, and the enolate formation will be takes place, and there will be steric electronic interaction between pH and oxygen. So this will be unstable. Now when it will take from this side, the proton that will resonate to this and this will be open up. So enolate, in this enolate will be formed, that is more stable enolate. And when you treat it with Br2, what will happen? There is a bond between oxygen and hydrogen that will come here, and then this will attack to Br2, that is the anti-bonding of Br-Br bond. So this CH2 will attach to Br. Now if you see this reaction, pH and this group are in trans to each other. So this will be predominant. I don't know why it is not showing. Okay.